Very glad to be the host today and to introduce to you Professor Dr. Chankyung Park, who is a computational social scientist.
I like the tone.
So that's quite an interesting description, and I think we will experience an even more interesting talk today, which I think is very interesting from a couple of perspectives, and so I'm really happy that you found the time to join us, and I'm also happy that we already have a couple of visitors online, and we'll see how it will develop. If more people will join us, it's still early in the afternoon. So the setup is that the talk will be about 30 minutes, and if it's like 40 minutes, I probably will spam you in the chat of Zoom probably.
Okay. I'll try.
And from that we have plenty of time to go into a fruitful discussion. So normally our speaker is sharing his screen for the slides. So so the floor is yours.
Okay, thank you very much. Thank you for the great introduction, and thank you so much for inviting me here. I will try to share my screen if I can. I spent a whole semester doing Zoom for teaching, and I'm not really good at this. Yeah. Although I'm a computational social scientist. There you go, I think. Do you see my screen?
It's perfect.
Okay, that's great. Okay, hi everyone. Again, my name is Chankyung Park. I'm an assistant professor at Beijing Normal University, Hong Kong Baptist University, United International College. Super long name, I usually call it UIC. The problem with that is if you Google UIC, it will spit out like usually University of Illinois, Chicago. But I just like the UIC, the shorter version. I will talk about the auditing personalized media with donated data. So I will try to propose a donation approach as a new approach of collecting data about the algorithm and platform companies such as Facebook, Twitter, etc., etc. For this particular presentation, we'll focus on Facebook takeout data, it's a specific type of data. And the donation approach is nothing fancy. It's essentially begging for data. So it's like we will contact with the research participants, and we will tell them, I know you can download data from your Facebook account. Please give it to me so that we can do research. I will try to argue that this is actually a very useful approach of getting data, specifically like trace data, compared to other type of trace data collection approach, such as tracking or buying data or scraping data. Okay, so and it gives us relatively accessible and cheaper, reliable way of getting data for a very important topic. And this kind of data collection can draw more scientists who are interested in research questions, not only from the academia, but also from civil society who's interested in the algorithm and platform in general. So that's why I say that this might be a method for poor scientists. Even if we don't have money and resources for like fancy data collection, we should be able to do something about this topic. So, and I know I changed the title a little bit. So I realized that this kind of the data collection and also the statistical methods I will try to propose here can be applied not only to the algorithm but personalized media in general. So that's why I placed the algorithm by personalized media here. And this is not necessarily a success story. This is a disclaimer because I'm still lots of these things are still ongoing. So I will argue that this kind of data collection is useful, but it raises lots of methodological challenges as well. And there is a way of avoid that kind of challenges, but that's still hard to avoid. So I will just, that's kind of the general story of the presentation today. And as I briefly mentioned, it's like 11 here in South Korea. So my brain stopped like a few hours ago. So I will stumble a lot. I'm sorry about that in advance. Okay, so a bit about myself. So I'm from South Korea, although I work for the Chinese university. But before that, I did my PhD in Michigan State, and I also worked as a researcher at the Korean Governmental Media Research Institute. And also, I worked near Bremen, not really near, but like not as far as South Korea. So I worked at the University of Amsterdam as a postdoctoral researcher. Also working on a certain project I will briefly mention in the process of presentation. And currently, I'm working as an assistant professor in ZeMKI here. So this is a southern part of China. Okay. And there are lots of like international colleges or campuses that are emerging in this Guangzhou area. It's a southern part of China, and also the area near Shanghai. Most of them are joint venture between the Chinese university and some other foreign university, like university from UK, university from US, etc., etc. So this is a very interesting aspect of Chinese higher education as well. Maybe that deserves some investigation on its own. But I'm working there, but I'm not there. Long story short, I was visiting Korea to visit my family a few months ago, and the COVID-19 happened, and the Chinese government temporarily canceled my visa, so I cannot go back to my campus. So that's where my office is. That's not necessarily where I am. Okay, so I'm speaking from South Korea, and that's why the COVID-19. So this is what city looks like, and this is what campus looks like. Of course, it looks much better than it actually is. You know, these pictures are always purposefully chosen. But like nice cities and nice campus. Okay, so I will. So these are a bit of motivation of my proposal. So I'm not going to spend much time on the motivation because I know that many of the scholars from the media field will agree on what I will argue here. So studying personalized media or studying algorithm is super hard because people see different things, right? So there are multiple reasons for that, such as recommendation algorithms and selective exposure and homophily, and also interdependence between them, right? For example, the recommendation algorithm will use the information about homophily, your friendship social network that exists in the social media, and the algorithm will use that information to give you some customized information, right? So that interdependence will complicate the what you see even further. Okay, and due to this kind of personalization, and also because you are consuming unbundled media, so it's not a bundled media anymore. So bundled, by bundle I mean newspapers and TV programs, etc., etc. But you're now consuming like small pieces of information. So when you see your media use data, you will see lots of short transitions across different short, very small informations. Right? So because of that, even not just researchers, but even the research participants, the media users, will be overwhelmed by the fact that they have to transit across different information. Because of that, their recollection is not accurate, right? So if we depend on the recollection-based methods such as repertoire mapping or survey, their recollection is not really accurate, and that causes a problem. And we have some studies that dig the kind of biases this kind of data collection process. Also, if you think about the lab environment to replicate this kind of media data, it's really hard to replicate the reality, partly because our data, our media use has this kind of shape, right? So we have a legacy media in the middle in the distribution of our media use, but in the long tail, there are lots of interesting stuff going on. And we are actually interested in this long tail in many cases, but like replicating this mix with a certain distribution across different types of media outlets is really hard in the lab environment. And also, the auditing the algorithm and studying the algorithm is even harder, partly because they are taking down the APIs. Right? So the recent study that is published in the Information Communication Society called this phenomenon the API colors. Right? So we are living in COVID era, but we are also living in post API era, and because there is no API anymore, it's really hard to scrape the data. It's really hard to get the data about the algorithm as well. And we can depend on data philanthropy. Sometimes platforms are willing to share their data through certain paths. API is one example, but sometimes they create the social science one project and they bring in some very prominent social scientists with lots of resource, with like ERC project or NSF project, and they share their data with them. However, relying on this kind of a data philanthropy might not be really reliable. And another way of collecting data about personalized media in the algorithm is a tracking study. So you can develop tracking software, and you can ask research participants to install those applications so that we can get the trace data from their machine. The big problem with this is expensive. It's costly in a sense that it is expensive, but also it creates lots of interdisciplinary work, and this interdisciplinarity itself creates lots of communication issues and takes lots of time to develop certain things, and social scientists have to understand the technologies, and computer scientists have to understand social scientists. It always creates a lot of problems. And in practice, it takes lots of time and money. Okay, so I have kind of typology, very like crude typology of trace data. So you can think of the scrape data. You can scrape from API or directly from website. And you can also buy data from companies such as a YouGov or Comscore. As I said, you can develop the tracking software. But the last approach I'm trying to propose here is donated data. So we can just ask participants to give us data. Okay? So I will just explain that in more detail later. Okay? So Trend has been the scrape data solution. The big problem with this is that the scrape data is all about behavior. Right? So if you think about the Twitter data you scrape from the API, Twitter API, it's all about information sharing or liking, following certain brands, and it's about like active behavior. But if we are interested in the something like instant exposure, it's not necessarily about active behavior, right? So you didn't do anything, and you didn't necessarily seek news information, but somehow you are exposed to news information, certain type of news information. And if you're interested in that kind of research question, it's really hard to get information from the scrape data, because scrape data is all about active behavior. And also, there, as I said, platforms are taking down APIs, and that's another reason why scrape data approach is kind of going away. It's still there, but people talk about the challenges from the scrape data approach a lot, more than before. And there are commercial data pools. So a big problem with this is that it's really hard to customize for your research questions. And how they collect data is that they usually maintain the panel, and they ask these panels to install the tracking software, and they occasionally ask questions using the pre-designed survey questions. So they already have the survey questions, and if your research question is not well aligned with this pre-designed research question, then you don't really have good survey measures from them. Sometimes you can customize the questions, but it's super expensive. And one interesting story that I have is that when I was working at University of Amsterdam, because I was working with the ERC team, it was well-funded project, and we approached YouGov, which is like a big company that has this tracking panel, and we asked for a quote for a certain type of data, and all they said was, "We are super expensive; you cannot afford it." So that was the only answer we received. So I guess that they're super expensive, right? So there are only limited teams of social scientists who can use this kind of data. You can't even like name a few, right? So it's actually great like big barrier to the social science community who are interested in the algorithms and personalized data. Okay, so we have two remaining approach. One is tracking, and another is donation. And yeah, so my big motivation here is that you have to make research feasible again, right? So to make the research feasible again, you have to come up with some cheaper, independent, and the reliable data source. By independent, I mean independent from the platform companies who can have the data. And the data should have some outcomes of automatic classification research. Okay. So that's the kind of motivation that I'm trying to propose a donation approach as a kind of feasible, more accessible, and reliable data collection approach. Okay, this is another disclaimer. So what I will present from here is based upon the teamwork. So everything is based upon the teamwork. When I talk about the tracking study, it's from the team from the ERC at the University of Amsterdam. Okay, so that is led by Magdalena Boschisczak. I always have a hard time when I try to pronounce her last name, and she always says that's wrong. But like Magdalena's there. And the donation approach is created and proposed with the team from the Michigan State. So this team is led by Kirsten Wilson. Okay, so a bit of Prelude. So this is something, this is my experience in the tracking study, and I'm still a part of this tracking, more expensive approach to the personalized media data. Okay, so this study has the name, the title, Citizens Exposed to Dissimilar Views in the Media Investigating a Backfire Effect. So our broad question was when we are exposed to like-minded versus dissimilar content, and when this like-minded or dissimilar content amplify or attenuate effective polarization. So it's not necessarily about like traditional polarization, which means the distance between your idea from your enemy's idea. It's more about your emotional like hatred or your negative feeling toward your output. Okay? So I'm not going to talk about the kind of substantive content of this project, but I will just give you the kind of workflow, how this works. Okay, so what we do for this project is that with a survey in the Netherlands and US and Poland, and we ask the research participant to install the open source software that is called Web Historian. So it was actually developed by one of our team member, Erica Trevino. And this is open source. That's the beauty of this, one of the beauty of this project. And the tracking data is essentially the list of the petabytes of URLs. Right? So once they are ingested to our server, you can just actually open those URLs, and then you actually did open and then scrape the data, scrape the web page, and analyze the text to categorize those texts, to which the research participants were exposed. Okay? And then we try to connect this classification outcome with their survey measures. And this is like 3 waves of surveys in a year. We also embed the online experiment. And this thing is still going on. But you can already see that how expensive this can be, right? So you have to have the server, you have to maintain to ingest all the tracking the terabytes of URLs, and you have to open the URLs using some scraping software, and then you have to download the data, and then you have to apply the artificial neural network to classify the content, etc., etc. So this is super expensive and cumbersome project. Although this is super exciting, I'm super excited about this, but this is very challenging and costly. This is the GitHub page. You can go to see the code of the web history software. So if you have knowledge in the Python Django and some database and the JavaScript, you can actually use this. I mean, in theory, it's kind of hard to implement right away, and maybe it's a better idea to contact with Erica to get some hint about this software implementation. But it's there. It's some resource you can actually use. So research participants went on the survey, and they are led to the web history page. This is kind of informed consent process as well. And they agree on this participation. They will lead to the Play Store kind of interface so that you can download this software, and it will be installed as a Chrome extension or Firefox extension. And then, of course, for the ethical reason, they should be able to search through your web browsing history so that they can delete some of the web history that might be sensitive. Okay, so this is something going on. I'm not going to spend too much time on this because this is not the point of the presentation. But all I want to say is that although this is super promising, it takes a lot of cost. So donation data approach is another way of collecting this kind of trace data. Okay, so one can extract information about liked pages and Facebook's categorization of the users for their advertising from their personal account. Okay? So this is the data source we are trying to use, and this is a rare source of information about the outcomes of algorithmic classification. Okay? So and I think this is super important. This is likely to be available for other platforms as well in the near future in the light of GDPR. Okay, so not just GDPR, but some other data protection law in other countries as well that tend to protect the access right of media users. Right, so they should be able to access to their personal data. As far as this access right is preserved, they should be able to download their own data, and we should be able to ask for data. Right, so that's kind of the logic that this might be a more reliable way of collecting the data. We already have a paper that is published in the Information Communication Society in this year, actually last year. The title is The Algorithmic Inference, Political Interest, and the Exposure to News and Politics on Facebook. So you can consider with this paper for the detail of the data collection. But the current data that we have is the U.S. Census representative data, and yeah. So there are a bunch of people 2,200 participants who actually answered the survey. The interesting thing is that if you request your personal information from the data from Facebook, it will take a few minutes to generate data. So depending upon the setting, actually it can take a few hours even. So you have to, as a researcher, you have to be very specific about the specific data you really want from the research participant. Anyway, research participants finish the surveys, and then they actually upload the data. That's why there are way more research participants here, and there are only 400 data donors actually. And this is kind of nice thing because you can actually compare survey measures of non-donators and survey measures of donators, and maybe you can use that information to fix the selection bias, potential selection bias. I will talk about that in a minute. So this is kind of the interface. If you go to your personal account, then you can download the information. This is what it looks like, your personal information. So these are the bunch of pages you liked. Okay, I liked. Okay, so as you can see, there are a bunch of computation stuff I liked, and there's always like one animal I'm obsessive with. It happened to be raccoon like 2 years ago. And so these are liked pages. And if you go to ads, then that's the advertising category that was generated by Facebook. Okay? So once you clean the data, what you get is two big matrices. Okay? So here, this is something, this is very like a user data matrix. Okay? So each row is individual the research participant, and each column is a certain page that this person can potentially like. Okay? So if this person liked this Mitt Romney page, and this should be 1. If he or she didn't, then it should be 0. Okay? So it's a bunch of like 0, 1 data. And if it was like advertising categories, and these columns are advertising categories. Okay? And if Facebook categorized you, the user 1, as a Mitt Romney category, then it should be 1. If it didn't, then it should be 0. Okay, so we did kind of path analysis. I will so you can consult with the paper that I just mentioned. So we did a bunch of path analysis to compare the homophily, the direct effect of homophily, so direct effect of having politically interested people, and indirect effect of homophily. So the algorithms kind of see that you have lots of politically interested people, friends, and then use that information to give you more politics-related information. That's kind of the indirect effect. Okay, so we did kind of comparison between direct effect and indirect effect for homophily and customization. By customization, we mean that people like a certain page to signal the algorithm. And we did comparison between direct effect of selective exposure and indirect effect of selective exposure. And the interesting thing is that for homophily and selective exposure, direct effect was much larger, but the customization behavior, so your liking behavior, only signal algorithms. So there is no direct effect of looking at seeing more political content or news because you like a certain page. But there was lots of indirect effect. So algorithm used the information that you actually like a certain pages. So that was a kind of interesting finding could identify from the data. And we also did the qualitative approach as well. So algorithm itself is not the only thing that matters, of course. Data also can matter. So when people say the garbage in, garbage out, data quality actually matters for classification outcomes, right? So we also thought that the categories itself, that the labels itself can be very important. And how Facebook comes up with those labels for classification is in a black box. There is a certain business conference that where this kind of labeling is discussed, etc., etc. But we don't know exactly. But there is a certain way of labeling people, and this labeling itself might have important impact. So one thing we try to do here is to apply a discourse analysis to categories, as if categories are a text. So I'm not going to talk about the research here, but there are interesting metadata you can use from the Facebook if you register yourself as an advocate. Yes. Okay, so that's that. So now, the progress we have been achieved so far actually use kind of a qualitative approach and hand waving approach where we actually aggregate the data, the lots of zero ones, to get very simple proportion and very simple counts, etc., etc. But what if we want to use data more direct way? And we actually we face a very important the methodological challenges. And one is selection bias, and the second is data sparsity. So I will try to talk about the statistical methodology I'm working on to avoid this kind of issues. It's not there yet, but I will give you some ideas about my ongoing research. Okay, so as I said before, this is the kind of data, what the data looks like. And the donation approach poses methodological challenges. First, as I said, like selection bias, because there are only a specific type of people who are willing to give us the data. Right? So there must be a big selection bias, and we want to correct that with a certain method. So that's one the problem we want to overcome. The second is the larger p small n problem. So so it's essentially a data sparsity problem. So you have a small number of n because there are only a limited number of people who are willing to give us data. But you have very wide metrics, right? Because there are thousands of pages you are possibly like. Okay? So in very traditional statistics, always the n should be larger than p, and this assumption is broken here. Okay? So how do we do this? Go with this, right? So that's another problem we want to overcome. And it's kind of the following problem is that there will be lots of zeros, right? So this person might be aware of the existence of Mitt Romney, but this person didn't even know the existence of Gay Rights pages, right? So there will be a bunch of these kind of pages, and there, as a result of that, you will see lots of zeros in this matrix. Okay, so first of all, let's talk about the selection bias. So we can think of like two types of selection bias. One is bias on level. Okay? So donators might have different characteristics from those who opt out, non-donators, right? And the previous studies actually identified the several factors that might be related to, associated with the donation behavior. Survey incentives and sponsorship, option to opt out, and privacy security concern. This is one thing lots of researchers actually pay attention to, and device skills were certainly experienced in the platform. And we actually found similar biases in our data as well. So this is the difference in measures between the donors and non-donors. Okay. So for all the measures in our survey. Okay. So these blue bars means that the non-donators have larger value in those measures, and this red bar means that donators have larger value in those measures. Okay. So essentially, the first group that had the greatest difference is about like heavy use of Facebook, reliance on Facebook for information, etc. So these are very interesting substantive variables. And the second group with like a moderate size of difference was about active use of Facebook and good understanding of the platforms, etc. And very interestingly, the social demographic variables and for the privacy concern, actually there were small differences between the donators and non-donators. So the privacy concern matters, kind of, but there are many other characteristics that should be the interest of a social scientist with much larger differences. And social demographic data matter, not so much. And this is actually very important because when you want to correct the selection bias with some statistical method, you usually depend on demographic variables to correct that selection bias. But this traditional type of statistical method might not work because the demographic value measures between the donators and the non-donators didn't have much difference. Okay, but more fundamentally, does this matter for analysis? because social scientists are more interested in the relationship of the variables rather than absolute value, absolute difference between the donators and non-donators. So we created this big correlation table, that kind of visualization table, for every possible pair between the variables. Okay, so this is the old sample, donators plus non-donators. And you see a nice like red colors, which means that like overall positive relationship between many pairs of the variables. And when you look at the non-donators, actually you see the flipped correlations. Okay? So for the customization activities and the partisanship and political efficacy, actually you see the flipped sign here and there. Okay? So this kind of the relationship actually has selection bias as well. So you want to fix that. There are multiple ways of doing it. One is traditional social demographic centric weighting, but as I said, because there's not much of difference in terms of social demographic variables, this might not work. Another way of doing it is something called inverse probability weighting. This is from the statistics literature. Essentially, what I try to do here is two-step estimation method. In the second step, you actually estimate the regression you are interested in based on the some substantive theory. Okay? So that's the regression you want to run anyway. But in step one, what you estimate is the propensity to donate the data. Okay? Because you have information, the survey measures about non-donators as well, you can actually do that. Okay? So using the predicted propensity of giving you the data, you can actually identify what kind of people are overrepresented in the donator group and what kind of people are underrepresented in the donator group. And using the inverse of that propensity, you can run the weighted regression in the second step. That's the idea. Okay, so you're kind of penalizing people who are very likely to give you the data using the weighting you get from the step one. Okay, there are other ways as well, but that's kind of too technical, so I will just skip that. And that's something I'm trying to do. So what I want to do is that these are the essentially the results from the second step estimation. So this is something you're substantively interested in, and this is the relationship you estimated from the donators plus non-donators, and this is the relationship only from the donators. And using the weighting method, you want to recover the relationship from the old sample, right? Using the weighting method plus the sample, the donator sample. Okay, it hasn't been too successful so far. So the big problem that we are suffering from is that the step one, the prediction step, is not super accurate yet. Okay, so the accuracy of this correction method really depends on the accuracy of step one regression, which is estimation of the data donation behavior, the data donation propensity. Okay, but as you can see, there are multiple ways of running the first step regression. For the second step regression, you don't have much option because that's driven by your theory. But in the first step, only thing you care about is the accuracy of propensity score. So there are multiple ways of doing that. I'm trying to even incorporate kind of machine learning type of nonlinear regression to predict the propensity score. So we're trying different things out. But this is the essential the direction we're pursuing right. Okay, the data sparsity problem. Okay, so again, this is the same table I showed you before. As I said before, this is like short and wide matrix, and it actually causes lots of statistical problem. What I'm trying to do here is that I try to come up with some latent factor, identify latent factor using this very sparse 0-1 matrix. Okay, so there is a non-identifiability problem because essentially because there is lots of 0 and 1s, and this matrix is kind of sparse. This is very similar to the rotation problem in the factor analysis. So even if you come up with some latent factor out of this matrix, you don't exactly know what that actually means. right? So you have to pin down the rotation in a certain way, and that's actually hard, right? So kind of running example here is that I want to estimate the left-right in the ideological dimension. But even if you apply the principal component analysis to this matrix and you pick up the first dimension of it, of the decomposition, you don't exactly know that is actually ideological dimension or not. Right? So that is a fundamental problem you want to solve here. Okay, so typical way of dealing with this in the previous literature is that you scrape the data. So you have lots of n. So you make this matrix much longer. And you filter some political keywords. So some keywords you know that they are political and use-related for sure. Okay, so you shorten the breadth of the matrix. So you make the matrix longer and you shorten the breadth of the matrix. Then you can apply usual statistical method. The problem is that because there aren't many people who are willing to give us the data, we cannot afford it. Okay, so we cannot afford throwing out the data. So how do we avoid this kind of problem? Okay, so this is a kind of the model I'm trying to come up with. So this is very similar to the item response theory political scientists have been using. Okay, so the user I, the probability that user I likes keyword J is dependent upon the distance between ideology of user I and ideology of keyword J. Okay, and using this model, we identify the ideology of a certain user and ideology of a certain keyword. Okay? So this idea is very similar to factor analysis. Factor analysis is, in the factor analysis model, you have product between the factor and the factor lowering, right? And by only looking at the Yij, you estimate both factors and factor lowering. Here, you have a more model, the theory-driven model, statistical model here. You think about distance between the ideology of certain user and certain keyword. And using that model, you uncover the ideology of a certain user and the ideology of a certain keyword. Okay? And then I call it augmented factor model because I'm trying to use the prior knowledge about ideology. Okay? So, for example, we already know that Elizabeth Warren is quite left in the U.S. environment, and we know that New York Times is kind of left, and we know that like Hillary Clinton is arguable. We don't exactly know, but she's kind of in the middle, like slightly to the left, right? So, and we actually have reliable estimation of ideology of these keywords actually, and Bayesian approach, statistical method, offers the natural way of incorporating this pre-existing knowledge, right? So because Bayesian method have prior belief about the parameter you want to estimate, and using the data, you update that belief, right? So you can feed in those prior knowledge as a prior belief about ZJ. Okay? That's the idea. And because you exactly know that for example, average of Warren had a value of -1 because she's left, and New York Times had a score -0.5, and you know that this score is essentially about political ideology, right? Because of that, the other parameter you estimate using this model is actually about political ideology. So you actually solve the rotation problem as well by feeding in your prior knowledge about some keywords ideology. So using this method, we were kind of successfully identify the score, the ideology score of different keywords. Okay, so the gay rights had a -0.13. Hillary Clinton had a -0.39, etc., etc. And here the -1 being the extreme left and the 1 being extreme conservative. Okay, so we can estimate the latent factor or some ideology if we have enough knowledge about a certain keywords. Okay, and you can fit in those knowledge as a prior of this factor model to come up with some latent score. Problem is that in terms of the estimating the ideology of the users, it wasn't too successful. So the y-axis here is reported ideology. So the ideology that was reported from the survey, and the x-axis is the estimated ideology, and this is the dot plots using that information. As you can see, the correlation is very weak. Okay, this might be because of the low selective exposure, so their selection is not really based on their ideology, but it might not be. So what interesting thing we observed from this plot is that you actually see gray dots here, especially at the extreme. Okay, which means that we have less information about these users. Okay, so it has a larger standard error from the estimation. So there is something called regularization in the machine learning literature. So if you have very small information about certain estimation, you automatically shrink those dots into zero. Okay? So once you shrink those dots to zero, you might have a stronger correlation between the reported ideology and the estimated ideology. So that's what we are looking for right now, and that's something, the direction we are pursuing. Okay, so I think I used lots of time. But there are a few takeaways regarding personalized media exposure and the algorithm curation. There is lots of speculation and workarounds for the empirical investigation, and recollection-based methods are not always accurate, and lab experiment might not be generalizable. And relying on scrape data and bot data have their own limitations as well. So there are opportunities in tracking and donation approach, but the interdisciplinary teamwork is imperative, and bridging over to scientific field and bioinformatics may provide solutions. Okay? And donation approach opens up the opportunities for algorithm audit studies by locating reliable data sources, but also pose unique methodological challenges. And I want to fix the selection bias and also the data sparsity using the statistical method I briefly presented. Okay. So that's it. Thank you very much.